2007 BC question 3. We have the graph of the polar curve r equals 2, that's the circle in the center, and r equals 3 plus 2 cosine of theta, which is the limacon shape there. And the curves intersect when theta is equal to 2 pi over 3 and 4 pi over 3. And so I've noted those there. And what we're looking for first in part A is if R is the shaded region inside the graph of the circle and also inside the graph of the limacon, as shaded in the figure there, then find the area of R. And you'd have to think about this for a minute, but there's kind of a straightforward way of doing this. And the straightforward way would be to use the circle as much as possible because that area is easy to calculate. And so, for example, if I draw those lines at theta equals 2 pi over 3 and 4 pi over 3, we can see that everything to the left of those, to the right, sorry, of those two lines is really inside the circle. And we could calculate that area fairly easily by, if that's 2 pi over 3, then that's 2/3 of a semicircle. The area on top of the x-axis and below would also be 2/3 of a semicircle. Altogether it's 2/3 of a circle. So we could say that the shaded area there is 2/3 of the circle with radius 2. And that would be found by that formula, 2/3 of pi times 2 squared, 2/3 times pi times 4, so you would end up with 8 pi over 3. And so that's the red shaded area. What we still need from this, though, might be the area shaded in green, which you can see is entirely inside the limacon. And so what that really is the area from 2 pi over 3 to pi of r equals 3 plus 2 cosine theta. That is the limacon. And if you recall, the formula for area of a polar curve is 1/2 r squared. So if I bring out the 1/2 and now I have 3 plus 2 cosine theta and I square that, then that will give me the area, that will give me the green, 1/2 of the green area. So I still need to really multiply that by 2. So we'll just call that 1/2 of the green area, so that A is really equal to the integral from 2 pi over 3 to pi of 3 plus 2 cosine theta quantity squared d theta plus the 8 pi over 3 above. And so basically now I have these two areas. I have the green area and the red area. And finally I need to add those two areas together. And since this is a calculator problem, I can bring in the calculator to find the integral that's still unresolved. And so I've entered that function. I don't need to put this in use the polar functionality of the calculator here. I simply have this function and I'm looking for the integral of that function from 2 pi over 3 to pi. The calculator can't actually find, if I graph the polar curve, it couldn't actually find the area inside the curve between two angles. We have to use the normal function capability. I'm going to zoom standard and integrate between 2 pi divided by 3 and pi, and you can see that I end up with 1.9928 or 1.993. So the last thing I want to do is to get an actual value for that. So I have 8 pi divided by 3 plus 1.9928 equals 10.370, and that gives us our answer for part A here. We'll continue with part B in the next video.